Hello, welcome everyone, and thank you for joining our live web seminar on 5G for Industrial IoT. My name is Sylvia Liu, and I will be your moderator today. I'm the head of Cellular Technology Strategy at uBlocks and Working Group 4 Chair at 5G-ACIA. I'm very pleased now to introduce our two distinguished speakers for today, Dr. Andreas Müller, who is the chair of 5G-ACIA, also head of communication and network technology at Bosch Corporate Research, as well as Dr. Affif Osseiran, who is a vice chair of 5G-ACIA and director of industry engagement and research at Ericsson. Just a little housekeeping before we get started. If you have any questions during the web seminar, please feel free to type them into the Q&A box on your WebEx screen. I will bring the questions up at the end, as we will have time for questions after the presentation. Today's web seminar is being recorded and will be available on demand after the live session. Now, without further ado, I'm going to hand the floor over to the chair of 5G-ACIA. Andreas, over to you.
Yeah, thank you very much, Sylvia, and very warm welcome also from my side. So great that so many of you registered for the webinar today, and hope that we can give you some insights in 5G for the industrial IoT. And it's, of course, the starting point of a series of webinars. We'll have more webinars coming in the following weeks, going then into more details for specific topics. And today's like the starting point to give you a general overview of the topic. And yeah, we want to keep this a bit interactive. So therefore, everybody is invited to join a live poll now. So there is the live poll tool. You should, well, I cannot see it right now as the moderator or as the presenter, but you can see it on the right side of your screen. And we would like to ask a couple of questions throughout the presentation, so to make it a bit more interactive and also to get feedback from your side. And before we start with the actual presentation, it's always very interesting to see who else is in the call and in the meeting. So therefore, the first question that we would like to ask you, and would be great if you could briefly provide your feedback, is simply which stakeholder group you belong to. Industrial 5G is about collaboration between the ICT industry and the OT industry, so the classical industrial domain, of course. But then we also have academia, and there are also other stakeholders out there, regulators, governments, and so on. So yeah, you should see the poll now, and would be very much appreciated if you can just click on the right category and then submit it, and then we should be able to see the results already. And there we go. So obviously about 50% of participants are from the ICT sector. OT is still a bit underrepresented, but maybe some come a bit later. And then we have a fair share also of academia and others. So I think that's already good input. And then just to continue, and that's then the last question before I start with the presentation, is it's also interesting to see, of course, where you're from. So next poll will be which region do you come from? Basically here split into continents. So it should also be very easy to answer, of course. So just make the cross at the right place and submit it. And then we're already curious to see where people are coming from. And it poll is ended, and there we go. So obviously the wide majority is from Europe. I guess also because of the time, of course, is particularly suited for participation from Europe, at least today. But as you will see, if you look at the plan for the upcoming webinars that we're planning, so we are changing the times a little bit so that it's other webinars might be more suitable for East Asia and others for North America. Okay, so but now we know roughly who is in the audience. So dominance of the ICT industry from Europe, But let's jump right into the actual presentation and start with a short introduction. So there's a lot of excitement about 5G, of course. And if you hear sometimes people speaking about 5G, you can get the impression that it's like a world with 5G will be like the land of milk and honey. So I just included a couple of quotes here from some famous forums or people. And this is just a snapshot, of course, of quotes and views that you can find out there. So the World Economic Forum said earlier this year, 5G is about to change the world in ways we can't even imagine yet. The Handelsblatt, the major German newspaper, said the 5G mobile communication standard is a prerequisite for the next industrial revolution. Then we have the CEO of Qualcomm comparing 5G with the introduction of electricity in the car, that it will affect entire economies and, of course, also benefiting entire societies. And we have even President Trump in the United States who learned about 5G and wants 5G and even 6G already as soon as possible, since it's far more powerful, faster, and smarter than the current standard. And basically, he's right, of course, and that's what we will explore a little bit during the webinar today. So a lot of excitement about 5G, maybe also in some cases, sometimes a bit overhyped, but certainly there's a lot of potential, especially also for the industrial domain for manufacturing. And that's what's indicated a little bit here. Why is that so? So the very new thing about 5G is its very strong focus on connecting all kinds of things in the Internet of Things right from the beginning. So previous generations always focused primarily on connecting phones, connecting people, but now it's about connecting factories, cars, machines in agriculture, healthcare, and so on. And this really right from the beginning. And that comes along, of course, with a completely new set of KPIs and capabilities. So my colleague Affif will deep dive us a little bit more into this later on. And this has started some time ago. Now we see the first deployments coming up. On the other hand, there is the trend towards the industrial IoT, the fourth industrial revolution ongoing. So we had 3 previous industrial revolutions, if we want. So the introduction of mechanical machines was the first one. Then the electrification, introduction of mass production conveyor belts, the second one. The automation of industry, which started in the 1970s, roughly. The third one, and now it's about the fourth industrial revolution. And connectivity per se is a key enabler for that, so that we have a fusion of the physical world of production with the virtual world from the IT domain. And this has started also independently of 5G a couple of years ago, 10 years roughly. And now we can bring these major developments together. That means bring 5G into manufacturing, into factories. And this way we can achieve unprecedented levels of flexibility, efficiency, productivity, and also better usability by the workers. So basically we can lift Industry 4.0 to the next level. So there's also a lot of economic potential, business potential behind this. There is a wide variety of different studies that you can find out there. I just included here a figure from a recent white paper of the World Economic Forum, again, the impact of 5G, which has been published earlier this year. And they basically included results from different sources in this single figure here. Because sometimes you hear, very different numbers. I mean, you could say McKinsey says $1.5 trillion as the global impact of 5G in general. IHS then 13.2, so that's completely different. But it's not completely different if you consider that these numbers refer to different times on the time axis. And so if we put all this together, we get this nice S-shaped curve. So typical market development, of course. And it shows the general overall economic impact in the long term indeed might be around $13 trillion in 2035 here. And if we look a little bit at this number in more detail, it boils down to different areas. And you can certainly see that manufacturing is basically the most promising area here. We have to be careful a bit because that's not exactly somehow the contribution to the GDP due to 5G manufacturing. It's more sales enablement, what they consider here, but it's still a very good measure by how much 5G will impact the manufacturing industry per se. If you look a little bit into more details, so there are 2 other results I included here. So the value to be unlocked by 5G manufacturing has been estimated by KPMG last year with more than $600 billion. So that's more than really the benefits also that 5G can unlock in manufacturing. And if you only look at the cellular connections, so the equipment and related things in manufacturing, so here ABI Research predicted a market of $10.8 billion by 2030. So in general, really huge numbers. And even if there is some uncertainty in the order of several $billion or so, I think this shows there is a lot of potential behind it. And that's why it's really worthwhile to have a closer look at 5G for the industrial IoT. So to summarize this short look at these two aspects, we can say on the one hand, 5G will lift Industry 4.0 to the next level. We really can maximize the developments that already started quite some time ago. And on the other hand, due to this huge economic potential, Industry 4.0 also may become the killer application of 5G. So the huge economic potential is not necessarily in the established consumer world. I mean, these are saturated markets. It's very hard to earn more, to have a higher ARPU, our average return per user, for example. So the potential is, of course, in the new vertical applications. And out of these vertical applications, the industrial domain is one of the most promising ones because a lot of value is created in manufacturing, because there is a lot of potential to be unlocked. And also, we don't need nationwide networks basically to start doing things there. And if we consider all this together, we can say 5G for the industrial IoT is really a crucial factor for whole economies and societies. So it's not just about a slightly better Wi-Fi or so, but it's about a huge impact on the world as we know it. So I hope this already stimulated your interest a bit further, but I guess you already have been quite interested when deciding to join the meeting. So that was the high-level overview a little bit. And now, of course, the question is, why is 5G so different and how is it different? How may it support now these industrial use cases and so on? And here I would like to hand over to Affif Osseiran from Ericsson, who is the vice chair of 5G-ACIA, and of course, who is an excellent expert to give some more details on that. Affif.
Thank you, Andreas, and warm welcome from me as well. Now let's stick to basic at the beginning. You might have seen these kind of picture before, but it's important to start with it and with the simplification where we are in terms of the 5G journey and what we are trying to support. As you know, the construction, we have tried from the beginning to support vastly 3 different categories. And you can see them: enhanced mobile broadband, massive machine type communication, and critical machine type communication. When 3GPP terminology, we more use the URLC connotation. And so those are from agitators, sensors, up to, like mobile robots, still supporting online gaming. So these are example of use cases. Having said that, there are many use cases do not fit entirely in this, categorization, and this is not a surprise. Some of the categories, like cameras, for example, they might be massive in terms of deployment and require highly more data rates. When it comes to the requirements, and has been said by IMT 2020, and this is fulfilled by 3GPP releases 15 and 16, we'll come back to it, is different kind of requirements. First, of course, latency is important, whatever, on the user plane, achieving 1 milliseconds, although on the control plane, 10 milliseconds. The density connection, 1 million devices per square kilometers, reliability 99.990. The data rate here, even it shows 20 gigabit per second, but in essence we can achieve more if we can aggregate, for example, like 2 carrier of 400 megahertz. I guess we can, it has been shown we can achieve even 35 gigabit per second. The data rate on the uplink, at least 10 gigabit and even more. The peak spectral, if these are peak, of course, the peak spectral efficiency on what is required is 30, but you can even achieve up to 44 by using, for example, 264, 56 QAM, etc. And not to forget the battery life, and of course to have a smooth transition. That's why mobility interruption should be very, very low. And now, if these are the applications, where we are in terms of the standard and the journey, and this is exactly what I'm going to talk about it, next to show So if we move on to the next slide, you will see, where we are in terms of the journey. And the question which is coming again, what is the impact of the pandemic? There is, of course, an impact on releases 15 and 16, which are the core of the 5G and on R. There is no real impact. There has been slight, I would say, delay in release 16, few months, but this has been very minor. Now it remains to be seen what will be the impact on releases 18 and 19. On the radio level, we don't really know. On the SA level, meaning the requirement has already started. It's important here to note, for those of you that don't know much about 5G, like the requirements for massive MTC has been addressed already in release 15. It continues, as you can see from the arrow. Anyway, it did not really, it didn't stop. And the major feature of enhanced mobile broadband were addressed in release 15 and will continue in release 16 as well. The critical aspects, you have certain part in release 15 and 16 and a little bit 17. I will show it later in the next slide. If you move on to the next slide, here I have chosen few features, especially in relation to industrial IoT. For example, what have we done in release 15 in particular? To have a shorter transmission time, meaning it will allow you, of course, to reduce your latency, to be able to pre-schedule ahead. So this will increase as well. You will decrease your latency. You have a more robust mechanism. You duplicate the information. It allows you to have a higher reliability. In release 16, additional work item has been added also to make enhancement like industrial IoT work item, like non-public network. In release 17, has been, most of it is release 16 with the exception. There is a new work related to URLC, is about what is called XR evaluation. When it comes to the massive aspects, there is the LTE-M and narrowband IoT are evolving, and now we would like to see more support for more capable devices. So not only very low data rate, but maybe middle range data rate. So this is what previously this kind of use cases do not fit entirely under the massive MTC. So this is in a nutshell some of the features of that are helping to achieve the requirements of the industrial 5G. Now, if we have a look where we are in terms of the journey, how many connections and how are we evolving? So the latest facts on the table, if you can see, this should be, of course, June 2020 and not June 2019. The report has just released 10 days ago, where in terms on the cellular IoT, now I'm not talking only about 5G, mainly cellular IoT, we almost last year achieved 1.5 billion connections, and these are from massive to broadband to critical. And the growth is pretty strong. It's 23%, per year. A growth, pretty promising. And the pandemic, we have not seen any impact for the time being. And to put it into bigger perspective, like a year, end of 2019, we achieved almost 20 million 5G connections, and by the end of this year, it will be like tenfold, almost 200 million subscription or connection, which is really, so 5G is really growing very fast, including basically support for cellular IoT. And now I would like to get your opinion, of course, as well. What do you think? I've shown you the subscription figure, but from your perspective, when do you think 5G industrial IoT will happen? Is it now, next year, the year after? So soon, you should see a poll. So please basically express your opinion. And of course, I will complement it by additional information when the devices will be available or are on the market. So please go ahead. So when do you expect industrial IoT from your perspective will take off? Is it this year, next year, in 2 years' time, or even after 2025? So it will be interesting to know your opinion. So you have few seconds to go. Okay, and now we are done. Let's see the results. What do you think will happen? Okay, the majority think on 2022 and beyond, some 2021, which is good. I would like to add one information, of course, on the devices, capabilities for URLC. Will not happen this year. We have to wait 1.5 to 2 years. So in order to have the whole, basically, I would say categories, then we have to wait at least till 2022 and beyond. So thank you. Now let's move to the use cases and where we are, and Andreas will lead us to that.
Yeah, thanks, Affif. So now after we have heard a little bit more detail from Affif, what 5G is all about, what makes a difference, and also about a rough timeline a little bit. Of course, the key question is always, okay, what can we do with that in manufacturing in particular? And basically, this slide here should give a little bit an overview of the general application areas of industrial 5G on a relatively abstract level. But then later on, I will deep dive into a couple of use cases. First of all, of course, it's suitable to connect mobile and portable assets, so be it forklifts or automated guided vehicles, or also tools that you may use in production. It's suitable for connecting moving or rotating parts. So traditionally, we use slip rings and drag chains and so on in these cases, but nobody really likes that. So if we can get rid of them, we can save costs. It simplifies the maintenance because we don't have to replace them from time to time. And also we may be able to build machines in a more compact and flexible way. Then, of course, wireless sensors. So especially if we have battery-driven sensors, then we don't have to lay any cables. We just put the sensors and they are connected. Human-machine interaction is a very promising field, be it augmented reality, virtual reality, or also just a mobile control panel, mobile operation panel. Positioning and tracking is a very big topic. So in principle, we can use a 5G network not just for connecting devices, but also for locating devices. And knowing where things are in general is a very valuable information in production. So we can use that for assets tracking. We can use it to support the navigation of automated guided vehicles and many more things. And ideally, of course, this comes integrated with one infrastructure so that we don't have to run and operate different infrastructures on the shop floor. Then 5G is also a big enabler for a highly flexible and modular production so that we have different machines, different modules, which we can flexibly combine to produce something new, for example, without having to lay cables again. And we just put the module in there, it connects automatically to the environment, and then we are done. Retrofitting is a very big topic so that we can easily upgrade existing machines, existing plants by adding sensors, for example, and other devices. And in general, of course, 5G has the huge potential to lead to a convergence on the factory floor. So currently we have different wireless technologies and wire technologies in use. There might be Wi-Fi for connecting laptops, then maybe ultra wideband as a positioning solution, maybe then Zigbee for wireless sensors. So a variety of different technologies, and 5G with its flexibility and also versatility might be able to replace many of them. And that's an immediate benefit. I already mentioned that briefly. So then we don't have to set up and operate multiple networks in parallel, but we only have one infrastructure that can satisfy all our needs in the ideal case. So that's a very high potential of 5G. If we look at some of the requirements, and that's really just a snapshot to give your gut feeling of what we're talking about in production. And these are somehow also, of course, extreme requirements, but there are use cases, if we think of closed loop control applications, for example, where we really have a need for very low latencies down to the 1 millisecond level. Also, high synchronicity is required in many cases. So 1 microsecond is one key KPI here. So synchronicity means that the clocks in different devices are tightly synchronized with this accuracy here. We also have very high data rate applications in many cases. So if you want to connect cameras, for example, for visual inspection, or if you have augmented reality, virtual reality, there might be a high device density. If you think of a plant in the process industry with many sensors and so on, so then there might be many devices on average in a certain area. And this is also something where existing wireless technologies often fall short, because at some point it doesn't scale anymore with the number of devices, but 5G and cellular technologies in general can do very well here. And last but not least, there are use cases, many use cases for which we require a rather high communication service availability. Affif already mentioned the 6 nines, and also very high reliability, because industrial communication just has to work. It has to be reliable, right? And in the worst case, if it's not reliable enough, then the production stands still. Nobody wants that. So that's why we need this high level of dependability, and with that of communication service availability. But these are just some selected requirements to, as I just before, give you a little bit of feeling. And I would like to briefly deep dive a little bit into 4 different use cases. So the first one is what many people are always talking about, automated guided vehicles, so that we have these autonomous units which are driving around on the factory floor, for example, and taking care of the supply of goods and material. And there's an immediate benefit if you use 5G, because with 5G you can achieve rather good coverage and a high reliability. So if you also want to have connectivity in the last corner of the factory floor, for example, or if there are many obstacles, of course, in a typical factory, then it might be rather difficult to achieve good coverage everywhere. But 5G, which of course is also made for achieving good area coverage and so on, is very well positioned in that space. Also, positioning might help here. Briefly mentioned this already, to support tracking and navigation of HAVs. Typically, they have some other sensors on board. But if you do sensor fusion, for example, this may help that you can use cheaper sensors on the device, and also to help to improve the accuracy in general, and also maybe the speed or the time needed to get an accurate estimate of the location. Then this ultra-reliable low latency communication, URLLC, can be used for offloading intelligence from the HEV to the network, to a local edge cloud, for example, so that we offload, for instance, control functionality to the local cloud. And with this, we can keep the end devices, the HEVs themselves, simpler and cheaper, and then really close the control loops over the air. So that's something that you do not necessarily want to do maybe with a Wi-Fi connection, because it's not real-time capable enough, not reliable enough. But with 5G, that becomes possible. And finally, there can be quite a number of sensors on the board, of the HEV. So cameras, other sensors for sensing the environment. And even these different sensors might have different requirements in terms of quality of service. And 5G also can support basically this variety of different applications, and guarantee different levels of quality of service for different devices. So that's also something that can help here. So that's just also some short insights in the benefits here. Another use case are always wireless sensors and actuators, for example, in the plant and the process industry. So here we often have very large areas where we want to connect a sensor, which is maybe 1 kilometer away from the main building. And we have rather harsh environments. That means wireless connectivity per se is very attractive here, because then we don't have to lay cables. We save costs for the copper and so on. And we need a very robust wireless communication, because we often have rather harsh environments. I mean, if you look at such a process plant here, there are many obstacles, many reflections, diffractions, and so on. It's a very demanding propagation environment. The installation becomes easy and inexpensive, especially if we have battery-driven sensors, for instance. Then we just put it and it's connected, and we can use it. That goes hand in hand with easy retrofitting in general, not just in the process industry, but in general, retrofitting of sensors to existing plants and machines. And also here we can support this high device density that I mentioned already. So if we have many sensors, for example, in addition to other devices, and we want to use them in parallel, of course, so then we have needed communication technology which is able to support this huge number of devices, and 5G also promises to do just that. And then on the second slide here, of course, augmented reality, virtual reality is always a very attractive use case. And in general, there's a lot of potential behind AR and VR in manufacturing, for example, to intuitively support workers on site for training, monitoring, maintenance, or quality control purposes. Of course, there's more than that. And the question is, why do we need 5G for that? Of course, you could also have such a pair of AR glasses here using a cable. but especially manufacturing, that's not desired. So ideally, you can walk around with that. You can monitor different machines without having to worry about this. And 5G and connectivity ensures the high level of quality of service that we need and high ease of use because we don't have the cabling. And also here, if we have low latency communication, in addition to the high data rates, then we may also think about offloading intelligence, for example, the video processing, which sometimes takes place on the device to a local cloud. This gives us the opportunity to come up with cheaper devices and also maybe to increase the battery lifetime and things like this. And here then it's really important to have low latency because otherwise if you offload this and the latency is too long, then you simply get sick after some time. And the last thing that I would like to outline here is TSN over 5G. So time-sensitive networking over a 5G system. TSN in general, which basically corresponds to a family of IEEE standards, is a key enabler for the next generation of industrial Ethernet. Currently, we have many different industrial Ethernet solutions in place for historic reasons primarily. And there is the trend towards moving to TSN also in the wired domain. So that's ongoing as we speak. And the nice thing is that 3GPP has picked up these developments and basic or many TSN features will be supported by a 5G network starting from release 16 out of the box. That means we have a 5G system with a user equipment, the radio access network, and the core network. Then 3GPP specifies basically these translator units here, components here. And then to the outside world, the whole 5G system appears like a logical TSN switch. And that's really powerful because this allows for easy and smooth integration and migration of 5G into production. And also because it's then a major building block for the highly modular and flexible production that I mentioned before, so that we can easily connect different modules. That would be a control-to-control use case, as we say in manufacturing, but can also be used, of course, for the communication between a controller and a field-level device. And as an application developer, you don't really have to worry whether it's wired TSN then or TSN over 5G. So the future will speak TSN whatsoever. So that's just a brief snapshot, of course. So we'll have another webinar next time with a deep dive in use cases and requirements. Now we just would like to squeeze in another short live poll. And of course, we would be very much interested also in your views. So which use case you consider to be most promising, and maybe we can bring the poll up. So that's just a selection of use case. AGV stands for automated guided vehicle, AMR for autonomous mobile robots. So it's a little bit similar like in AGV, but usually on top there is still a robot arm. Then we have augmented reality, virtual reality, assets tracking, retrofitting, wireless sensors in general, and also TSN over 5G. And would be great to get your views on which use case you consider to be the most promising one. So, and the time has ended, and obviously there is a mixed view, as we can see, but it's not very surprising. Somehow I mentioned this already, that many people see a lot of potential behind AGVs and AMRs. And I think that's also natural because these mobile use cases, there is a need in any case for wireless communications, and then 5G simply might represent a big enabler for that as well. So thanks for that. And before handing over to Affif again, I just summarized here some important enablers now for use cases in the industrial domain. It's of course industrial grade quality of service, as we have seen, low latency, high reliability, and so on. But also then the opportunity to distinguish between different applications which we want to use at the same time, so that we can have a sensor next to a camera, next to a closed loop control application without any interference basically in between, in the sense that the applications interfere with each other. TSN over 5G, I mentioned that there's another huge topic that we will hear more about in a couple of minutes, non-public networks, so that we have somehow decoupled network from the public network, and also integrated positioning, which in general has a huge potential in manufacturing, as I mentioned earlier already. And with that, I would hand over to Affif again, who will now focus on some more technical aspects a bit in more detail.
Okay, thanks. Yeah, I will go a high deep dive, not really a big deep dive. So now the question that should be asked, how you deploy a private networks, and we have tackled this question in 5G-ACIA, 1.5 years ago, and we published a white paper about it. And this work also has been on the 3GPP basically level discussion, whatever ran in SA. It's very simple. You have basically different flavors if you would like to deploy a private network. Either you build it completely isolated as a standalone network and you choose basically how to do it. The spectrum is a different story, of course. I'll come back to it. It's also an important component. I'll come back to it in the next slide. Or you decide to build it completely hosted by a public network operator, for example, using network slicing. If you do it isolated, you should have your own, of course, radio access network. You should have your own core. You store your data within your vicinity, and you decide if you would like to connect it or not, basically, to the public network. In between, you could have a shared model. Of course, operators do have kind of they share the RAN, but also you can mimic this kind of model to apply to private network. So for example, within the factory, you can decide you would like to share the radio access network, the base station, where you can see it, now having two colors, blue and red. You keep nonetheless the control plane and the data in your factory for several reasons. Maybe it could be for security, or as well, to reduce latency. You could have another flavor, the control plane. You can place it as well and as part of the shared network. And classically, of course, you can decide completely to host your network as mobile network operators. They provide the network, they provide the radio, they provide the core. This is a simple solution. Now you might ask basically what kind of spectrum is it possible? There are different options, and I will show you. I mean, that's why you have different models globally. Some regulators has opted that the best way might be in have a local licenses. Germany has taken the lead. You remember, I mean, last year you could apply for spectrum. This was in the mid band, 3.7 to 3.8. Then, of course, other countries has followed suit. For example, like Japan. Japan was both in the mid band and in the high band. There are also others under discussion. For example, Poland this has been decided, even though here it appears because the information is from April, but things has evolved since then. You do have countries like the US, for example, is only CBRS. So it's not really, I mean, what we call local licenses. And other countries like Sweden are considering, is almost, but not 100%. The rules are not decided, both on the mid band. I don't see it here, but also mid band, high band. China has this, and this discussion, but if they will go through mobile network operators, that they will assign spectrum for industries, and this is almost finalized the discussion. And this is in the mid band, the discussion. So this is, I mean, it gives you a nutshell about the spectrum. Spectrum is important, and it will continue to be so. And remember, this is also connected to the deployment scenario. If, for example, you use standalone, then you will be able, 5G will be separated, and you could use, the 5G spectrum. You could also, I mean, this is you could use leasing. Operator can lease, and this is allowed in several countries. It's not here met, and I don't show it in this basically map. Now, there are other aspects which are also important. I have seen it on the chat. Security. How do you deal with security and within 5G for industries? The approaches has been different, I would say, from the OT and the cellular community. If you look classically at the OT, there are important features. If you go to a factory or to a mine or to oil refinery, I mean, those networks are physically isolated. For example, you refrain from connected to, for example, to the internet. Classically, you do define an area isolated perimeter where the user equipment processes. If you leave this area, then you can no longer connected. There are some regulatory compliances that are very important. This is IAC standard. And And the architecture, security architecture might change from depending on the deployment. Whereas in the 5G, this is completely, I mean, on the top, it's the same. There is authentication methods. You can use slicing for separation. And there is something very specific to Cellular is a SIM, where this is storage of a credential. And then you can do protection for jamming. So this is, about how we have been dealing, I mean, how security can be dealt in 5G for industrial 5G. And final things, I mean, as illustration, you can show from the figures OT zones where it's not possible. I mean, if you move from one zone to another, usually you cannot jump, like 2 levels up. This is for security reason. This is in a nutshell a security topic that we have covered within 5G-ACIA. There are other topics that we covered. Maybe we can show it very briefly for your information. We need to discuss it. But this is to say that there is a brown field. There is basically a family of industrial internet that need to be integrated, and TSN hopefully will help providing this basically integration. This will be the best fit. And we have made as well, we've studied and we made some recommendation how to do it, and we published a white paper. I recommend that you read it as well. So this is a very high, I would say, flavor what we have been doing, the topics within 5G-ACIA. So now I will hand over to you, Andreas, to move on to the 5G-ACIA overview.
Yeah, of course, we also would like to use this opportunity to give you a brief overview of what we are doing in 5G-ACIA. But this will be very short. So 5G-ACIA is all about providing a forum globally for bringing the OT industry and the ICT industry together. So if we want to make sure that industrial 5G becomes a success, we need a close collaboration between the different worlds. Previously, this have been disjoint ecosystems, so the telco world, the ICT industry, and the OT industry. But now we need this collaboration to jointly make sure that that becomes a success. And that's what 5G-ACIA is all about. So 5G-ACIA should help. So some major objectives are shown here: to establish a common language between both worlds. That sounds very simple always, but it's really very challenging that you know what you're talking about. So if you have talk about cycle times in manufacturing or transfer intervals and so on, what does this actually mean? Of course, it's also a way to reflect the needs of the OT industry, the classical industrial domain, standardization and regulation. Not every industrial automation company end user is a member in 3GPP. So we are discussing many things in 5G-ACIA and then prepare joint contributions which are presented and brought into 3GPP, for example, by the major ICT players. But it's also the other way around. So we also jointly analyze how 5G may really enhance industrial IoT, so how to make optimal use of it. We have discussions around TSN over 5G, for instance, use cases and so on, so that also the OT side can learn together with the ICT what to do with it. We are discussing testing aspects, for example. Certification is a topic which will certainly become more and more relevant. So do we need special certification procedures for certifying industrial devices? And at the end of the day, it's also just about developing a sustainable industrial 5G ecosystem. And that's also the goal that we have, to really reflect all stakeholder groups, all players in the ecosystem globally within 5G-ACIA. And last but not least, it's also about promoting industrial 5G worldwide. So here you can see an overview of the current members that we have. So we are 66 member organizations. Starting from tomorrow, we will be 67. So Redis is the latest member, will join officially starting from tomorrow. And you can see from the logo, so it's already really an excellent mixture between OT and ICT industry and also different regions in the world. But you can also see there is still some space left on the slide, so everybody's highly welcome to get in touch with us to learn more about 5G-ACIA and also to become a member if that's of interest for you. So that's our structure. So the main work is done in different working groups, and we currently have 5 of them. So in one, we are having really intensive discussions on use cases, requirements, and everything that is related to that, preparing also joint contributions to 3GPP. We have a working group on spectrum and operator models. So to discuss, for instance, what Affif briefly mentioned. So how can we combine different spectrum options with different ways of operating private 5G networks? Architecture and technology. So here we have activities on traffic modeling, for example, this TSN over 5G and so on. how to bring existing concepts in the industrial domain together with corresponding concepts in the ICT domain. So for example, the architecture that we have in both worlds, how can we align this, also the security aspects. Working group 4 is liaisons and dissemination. So about getting in touch with other organizations, marketing activities, and we have validation and tests, where we just started, for instance, a testbed framework and testbed activities. So these meetings typically take place as virtual meetings, even without COVID-19. In addition, we have regular plenary meetings 4 to 5 times a year. So these are supposed to be face-to-face meetings around the world. But recently now we switched to virtual meetings here as well due to COVID-19. And we have done once a year a general assembly, which took place last week, actually. That's about the elections and major decisions and so on. And we also have a board, which has the meta view on everything and works on the long-term strategy, for instance. And then Affif and myself, of course, also as part of the board. And last but not least, our office supporting this from an administrative point of view. And yeah, just as a short insight here, there's a picture we've taken at our last plenary meeting in September in Shanghai, which was a very nice one, of course. And yeah, we're really looking forward to going back to normal again so that we can have more of these face-to-face meetings in future, because then you have also all these coffee break discussions and so on, which actually are very valuable, right? So then this way you can easily get in touch with other players in the ecosystem. And that's, of course, extremely important, especially for this ecosystem development. And with that, I would hand over once more to Affif to outline a little bit the major achievements and so on that we've made so far.
Okay, thanks, Andreas. So what are the main topics we are discussing and we'll discuss and within 5G-ACIA and the major achievement? Starting from the topics, you have seen the deployment options that I presented. We had the white paper on gap analysis, which are basically the most important use cases and requirements. Then we now internally within 5G-ACIA will launch basically a testbed framework, may basically show hands-on what are we going basically collaboration among partners, how 5G is going to fulfill basically industrial requirements by doing demonstrations, live demonstration. Then the integration of industrial Ethernet, which I mentioned very briefly. We have worked on exposure interface, and there is a white paper just released yesterday. This is very interesting and important, basically how we make it simple to expose certain functionalities like device management, for example, to the industries. They can themselves control without the complexity of the OSS, BSS that inherently, that has been used in the past. Then there is, of course, the security aspect. There is many, study on the architecture currently. We had on network slicing. We'll have on OPCOA. This is a list. The achievement, I would say, first, the most important, then we are converging in terms of common language. You have seen security. I try, to explain it, and things has been moving really quite well. You see some kind of synergies and coming basically to a closer common language between the two. Those two basically sectors. Then not to neglect the contribution to 3GPP in terms of use cases requirements. This has become now basically very well known. What are the requirements for 3GPP? Then something that we are still working, of course, the establishment basis of the ecosystem. It's not only about requirements, it's all basically the stakeholder in place and basically moving toward also the commercial aspects. And we are being recognized of the industrial 5G initiative, and that's and we would like, of course, to continue like that. And the next, I would like to illustrate, this has been mentioned by Andreas, but just to show you, you can look at it basically offline, where especially the technical report 22804, the study on communication automation, this became a reference where we have listed the requirements, and this has been adopted by 3GPP. And finally, beyond basically those topics, of course, we collaborate with external fora since we cannot cover the whole, of course, range of subjects. For example, with NGMN operators, with IIC, with the 5G forum in Korea, etc. And currently we are under discussion for MOU with 5G in Infrastructure Association. So this is, I mean, in a nutshell, and what we have been doing. Now, I would like basically to ask you a question to you attending this webinar. If your organization is not 5G-ACIA member, if you are, you don't need to answer these questions. Are you interested in joining 5G-ACIA? So do you see an added value of joining 5G-ACIA? So do you have 15 seconds to do that? Perfect. I think now we are done. We can close it. Let's see the results. Okay, so 75% is yes. So this is fantastic. Of course, if you have more information, of course, you can come back to it offline. We'll be happy as well to explain more what we're doing. Now I'll hand over to you, Andreas, for a short wrap up.
Yeah, thanks, Affif, and I will try to keep it very short. So some takeaway messages. I mean, this was, of course, now a high-level overview. We touched many different topics, but it's just a starting point of this webinar series. So we will focus on selected aspects in more details during the upcoming webinars. I think what is important to take away is there's really a lot of potential. So industrial 5G may lift Industry 4.0 to the next level. We have to maybe completely rethink the way how we build a factory. And with that, there's also huge economic potential. And in general, manufacturing is one of the most promising new application areas of 5G. There's not just a single use case that you can say, oh, this is the killer use case, and this justifies already investment in 5G. At the end, it will be a wide variety of different use cases that makes a difference with very diverse requirements. But 5G may lead to a convergence here. And game changers, so capabilities of 5G are especially ultra-reliable low latency communication, this TSN over 5G, integrated positioning, and dependable quality of service. So these are really things that we do not have yet from other technologies. And I just want to emphasize this again, we really need this very close collaboration between the ICT and OT industries to be able to unlock the full potential. So that's something we have consistently in 5G-ACIA. You can see it from the mere fact that Affif from Ericsson and myself from Bosch are giving this talk together. And that's really required that we have this joint initiatives. So yeah, everybody's welcome to join 5G-ACIA, to at least get in touch with us to learn more. So that's the marketing part now. You can find more information also on our website, 5G-ACIA.org. There we've also published or can download all published white papers so far, and it's getting more every month, basically. And yeah, we'll be very happy to get in touch with you. And maybe we stop here for the time being. So thanks a lot for joining the presentation. And we still have a little bit of time for questions and answers. So I see there are a lot of questions available. And for that, I would hand over to Sylvia again. So Sylvia, back to you.
Indeed, thank you very much to you, Andreas and Affif. It's great and fantastic to hear your insights. Indeed, next we go ahead and we'll take some questions from the audience. Of course, there's quite a few questions. Since we're talking about 5G-ACIA, perhaps we will start with a very quick one. How often different working groups meet and discuss?
Yeah, maybe I can start with that. So it depends on the working group a little bit. But as I said before, so these are typically virtual meetings. That means 1 hour, 1.5 hour web meetings. And there are basically meetings every week. So even within the working groups, we have different work items on different topics. So typically people just pick the work items they are interested in. And then there might be dedicated calls on them. But I think, yeah, on average, there is almost every week a meeting ongoing.
Thank you, Andreas. And I also see a few questions addressed on the non-public network, you know, SA standalone, null standalone. There's a question about which one would be deployed first.
Yeah, I mean, we have
standalone or null standalone.
I can see, of course, I mean, non-standalone has been basically deployed, and it's not coincidence since it's rely on LTE. And since LTE it's here for a very long time. And standalone, we will see more and more. But of course, non-standalone, this is currently, I mean, still the dominant. And it will, I mean, I guess for many years, there is no, basically, it's difficult to make any forecast for the time being, the share of non-standalone versus standalone.
Mm-hmm. Andreas, if there's anything you want to add?
Yeah, I think, of course, non-standalone is possible and is available, especially for the classical public networks, because that allows for a smooth migration to 5G. If we talk about non-public networks and manufacturing, of course, typically we have a greenfield network that we want to deploy. So that means the target architecture in the long term certainly is 5G standalone, I would say, for most industrial players, but still, if you want to start early, then you would go for non-standalone first. Usually, you don't have to completely replace the infrastructure. Then Affif can say that better. If you want then to switch to 5G standalone once that's all available, but in the long term, yeah, it's really 5G standalone. And with NPNs, I mean, Affif already has given the overview of what is possible. So my view is always it's not black and white. We have these different flavors, how to set up a non-public network. There are many activities ongoing. Everybody, of course, is trying to understand what is needed, what can I offer, and so on. And probably we will, first of all, see a wide variety of different options to deploy an NPN. And then, yeah, so because the requirements are different, right? Whether we talk about a big company with thousands of people working in manufacturing, or a small SMEs, maybe with only 10 people or so. So these are different constraints, different starting points, and therefore different models might be optimal for one or the other.
Yeah, that's good stuff. Thank you, Andreas. And we have a question from Leo, ABO Research, about network deployment on the factory floor. Maybe this is a question for you, Affif, from your experience as well. And the question was about how many 5G base stations would you need to connect?
Yeah, I think it really depends how do you mention your network, isn't it? What are the use cases you are trying to cover, basically? And it's a matter of dimension. It could be 1, 2, 4, and it depends, of course, of the base station capacity. So it's not possible to answer basically in precise number unless you specify exactly your traffic and the use cases and you know, the dimension of your factory. Then it's possible. And then, you know, maybe I would like to add that I have seen a lot of positioning requirement. This has come to require, I would like to mention release 16 currently provide like few meters, which is not really like 3 meters indoors and 10 meters outdoors. So just to make sure people understand that. Thank you.
Yeah, yeah, exactly. That's a question I'm going to ask next.
Yeah, so it's not centimeters yet.
Yeah, I'm jumping back and forwards, but of course, lots of really great questions. So here we have one asking, could you specify few requirements presented, especially by the OT industry, and which one are the most challenging ones as you see for 5G? So maybe Andreas, could you share some of the tough requirements you've seen from the OT side which need to be addressed by 5G?
Yeah, absolutely. I mean, I briefly pointed this out in the presentation, but really it makes a difference. And we're also, the industrial domain is probably one of the domains which has the toughest requirements in some respects, especially ultra reliable low latency communication. So low latency, high reliability, together with a high level of dependability, so that we can really rely to get also these KPIs. So that's really challenging, and it's also what makes a difference then to the industrial domain, because it's, of course, if it's just about connecting a camera, so if it's a single camera, there are other technologies available. We can do that today, or we could do this yesterday already. But if it's then really about closing control loops over the air, what we see in the vision in the mid to long term, so that's something you would not do with existing wireless technologies, but this becomes possible with 5G. And that's why we really have to rethink the way also how we build a factory. If we think about use cases, and of course, many discussions are ongoing in 5G-ACIA. So first of all, you always think of the current status in a factory, and you think about, okay, where can I replace a cable, or what can I maybe make more robust, and so on. And it's okay. So these are the low-hanging fruits. But in the long term, we really have to understand and learn how to exploit the full potential of 5G. And this, when doing so, we may come up with completely new system architectures and things that nobody has thought about yet before, especially back to the quotes that I presented at the very beginning. So, but this low latency, high reliability, real-time capability, and then also the potential to really support this wide variety of different use cases and requirements at the same time. So that's what makes a difference with 5G.
Yeah, that's good stuff. Time is running out, and I'm going to just pick another follow-up question, and we will wrap up. So, can the academia have a role to play in this organization? As a academia representative, how do they participate in this organization?
Yeah, maybe I can also take that one. Of course, we also have academia as part of our membership. We have various research institutes, for example, which are members, and it's also important. So I was talking about OT and ICT, of course. So that's the companies and the business side, so which are required to make a substantial business out of it. But also academic input is required because academia typically is looking a little bit longer into the future and maybe has the more disruptive ideas, right? And of course, these inputs are very welcome. So we have already academic members, would be welcome also to discuss this with additional academic parties which are interested. And they, should also then become regular members, but they, in general, the membership fees, I would say, are very reasonable in 5G-ACIA, and it's not just so set. It's, if you look at the details, it would be really like that, and especially for academia, it's not overly expensive, I would say.
Okay, great. So
Sylvia, maybe there has been a question, basically, what will come first, the network, the devices, etc. I think usually how it is, the network is always can come first, but there is also, of course, a challenge. Will all the components be implemented in the network? And then we see also a challenge in terms of the device availability for especially URLC, critical MPC, because of the volume currently. I just wanted to emphasize that.
Yeah, thank you very much. That's good stuff, Affif. Great. So thank you very much, everyone. There are so many great questions here we received today. We will follow them up through emails because we have these great questions. We want to get in touch with you. We do appreciate you being with us today. I would like to point you to the next webinar on industrial use cases and requirements. Yeah, exactly. So here we show this slide here, which is scheduled on 21st of July. In addition, we have 2 more webinars, and you can find more information on 5G-ACIA website. So this brings us to the end of this webinar, and thanks again for joining us today. And of course, the recorded version will be circulated with a presentation as well, and we